Now let's talk about change of variables for triple integrals. Change of variables for triple integrals in principle is the exact same as we did it for two-dimensional integrals. We do the same steps. We substitute our old variables for new ones. We have to replace x with whatever the new formula is. We have to replace y with whatever the new formula is. We have to replace z with whatever the new formula is. We have to re-express our region of integration in terms of the new coordinates, and we have to multiply by an area distortion factor. We have to calculate this Jacobian determinant. We have to take its absolute value, and then we have to throw that into our integral to compensate for the fact that when we change coordinates, we might have accidentally distorted what the area is, or what the volume is in this case. So here's an example of a triple integral in terms of x, y, and z coordinates, the triple integral of x, dx, dy, dz, and we want to substitute in these three new coordinates. So what we have to do in order to do this triple integral is we have to A, change our integrand by substituting in the new coordinates. Then B, we have to change our region of integration to compensate for the fact that we've got this new system of coordinates. And then 3, we've got to change dx, dy, dz into whatever is appropriate to compensate for the volume distortion factor. In this case, we're going to be writing down a triple integral. X gets turned into 5u plus 2, like so. That's the first step. The second step is we have to change our variables. So, for example, we used to have z going from 0 to 1. But if z is equal to minus w, let's change this into du, dv, dw. If z used to go from 0 to 1, that means that minus w is the same thing as z. That goes from minus 1 to 0. If y is 2 times v, and y went from 2 to 4, then we would get 2 times v goes from 2 to 4. And so that means that v goes from 1 to 2. If I wanted to write this out in formulas, I would say I used to have 0 less than or equal to z less than or equal to 1, 2 less than or equal to y less than or equal to 4, and 3 less than or equal to x less than or equal to 6. I would take all of these and I would substitute in the new variables. So I would say that 0 is less than or equal to minus w is less than or equal to 1. I have 2 is less than or equal to 2v is less than or equal to 4. And I have 3 is less than or equal to 5u plus 2 is less than or equal to 6. And I can solve. This first one says that w is between minus 1 and 0. The second one says that v is between 1 and 2 because I can divide through by 2. And the third one, if I solve, I can subtract 2 from all three of these. I get 1 is less than or equal to 5, u is less than or equal to 4. And so now u goes between 1 and 4/5. So that's changing the region of integration for this integral. And now all we're left with is we have to calculate this Jacobian determinant. We have to find this 3×3 Jacobian matrix. We have to calculate the determinant and we have to take the absolute value. So we write down a 3×3 matrix, and in every row, we put the partial derivatives of our functions. So our first row, we put the partial derivatives of x with respect to u. With respect to v, it doesn't depend on v. And with respect to w, it doesn't depend on w. In our second row, we put the partial derivatives of y with respect to u, with respect to v, and with respect to w. And in our third row, we put the partial derivatives of z with respect to u, v, and w. So here are the derivatives of x, y, and z with respect to u and v and w. Then we take that whole matrix, we calculate its determinant. The determinant of this matrix is going to be minus 10, and then we take absolute value, and that gives us 10. Our area distortion factor is 10, and so we put that in front. So this triple integral gets converted into this triple integral.